Okay, let's look at the review here for the test. The first few parts are compositions, or the first part is compositions and inverses. So we have our f, g, and h functions. Number one says to make a composition of -1 between g and f, so g compose f of -1. -1 will go into the f function, and then whatever that is will go into the g function. So putting -1 into the f function, -1 squared minus 3 as 1 minus 3, which is -2. So putting -1 into the f function gives us -2. So now I'm going to put -2 into the g function, which is -4. So 2 times -2, which is -4, plus 3, which is -1. So g compose f of -1 gives us -1. Number two is f compose g of 3. So 3 goes into the g function first. So we'll go to the g function and put 3. 2 times 3 is 6, plus 3 is 9. So putting 3 into the g function gives us 9. And then I need to put that into the f function. So 9 into the f function. So 9 squared, that's 81, minus 3, so 78. So f compose g of 3, 78. This is the other way to write a composition for number 3. This 2 into the h function, and then whatever that is, into the g function. So putting 2 into the h function, 2 plus 4 gives us 6. Whoops, it's the h function. So h of 2 is 6. And then putting 6 into the g function, 2 times 6 is 12. Plus 3 is 15. So g of h of 2 is 15. Number 4 is the g compose h of x. Now, when we're not actually evaluating, and like in this case, the whole function has to go into g. So the whole h function goes into g. So g is 2x plus 3. Well, wherever the x is gets replaced by the h function x plus 4. That's the h function. And then we just need to simplify it to put it in standard form. So 2x plus 8, use the distributive property, plus 3, combine like terms, 2x plus 11. So the composition of functions g and h, g compose h, is 2x plus 11. That's an actual function. Number 5, f of h of x. So same thing, except it's the f function. So I'm going to be replacing the x squared minus 3. I'm going to be replacing the x in the f function with the h function. So x plus 4 goes inside the f function. So it becomes x plus 4 squared minus 3. This is a little bit more work to simplify because you have to multiply x plus 4 times x plus 4 and then combine like terms. Distributive property, x squared plus 4x plus 4x plus 8 would become this here. Combining those like terms gives us x squared plus 8x plus 8. But then we also have this minus 3 at the end that we're subtracting. So x squared plus 8x plus 5. So this composition function, x squared plus 8x plus 5. That's a quadratic. For number 6, we're doing an inverse function. So inverse function of f. So first we'll write the f function as y equals x squared minus 3. And since the inverse function has the input and the output switched, then we'll switch the input and the output here. So x equals y squared minus 3, and then we'll solve this for y to get the inverse function. So x plus 3 is equal to y squared. Square root both sides. So the square root of x plus 3, and that's our inverse function for f. So f inverse of x is the square root of x plus 3. This will undo what the original f function does. Number 7, we want the inverse of the g function. So the g function is 2x plus 3. We'll do the same thing. We'll switch the input and the output. So x equals 2y plus 3. And then we'll resolve this for the y value, which is the output. X minus 3 equals 2y. Divide by 2. And we get x minus 3 over 2 is equal to y. And that is our inverse function for g. So g inverse of x is x minus 3 over 2. For the h function, h inverse of x, which is x plus 4, okay, so this one's pretty easy. We got x plus 4, and we're switching the input and the output, so x equals y plus 4, and then we're solving this for y again, which is the output. So our inverse function, x minus 4, is our inverse function for h. So h inverse of x is x minus 4. Number 9 wants to know what the composition of a function and its inverse is. Well, so we just discovered, so the h function is x plus 4. The inverse of h is x minus 4. If you put x plus 4 inside, if you put x plus 4 inside here, you get x plus 4 minus 4, which is just x. And this is true for any time you compose inverse functions. Inverse functions cancel each other out and takes you back to where you started, in this case, x. Number 10 is the product property. You just multiply each of the exponents by 3, so x to the 3 halves, and y to the 1, because 3 over 3 is 1. This is the quotient property. You subtract the exponents, 4 over 5 minus 1 half. Whoops. Which is 4 over 5 minus a half. So that's 8 over 10 minus 5 over 10, which is 3 over 10. For number 12, we have x to the third. We have to subtract the exponents on the bottom, so subtract a half and subtract 3. I'm going to put this in the calculator real quick so I don't... Just so I can quickly do this. So 2/3 minus 1/2 minus 3. And that is negative 17 over 6, which we'd have to write it as a positive exponent, so we put it on the bottom, 1 over 17 to the 6th power. Is that what I have for number 12 there? Yeah. 13, we have to use two properties. We have to use the product property first, or the power property, to turn this into x to the 2/3 over x to the 1/2. And then we just have to subtract the exponents, 2/3 minus a half, to give us our, I don't know why I keep putting this equal sign here. So 2/3 minus 1/2 is 1/6. So this is x to the 1/6 power. Simplifying radicals, remember we're looking for groups of factors of 3. So 8 is composed of 3 factors of 2, so that reduces to 2. X to the 5th is composed of, you just have to divide the exponent, so you can bring a single x out, but there's a remainder of 2, so there's still x squared underneath. Sorry, not a 2, x squared, my mistake. There's still 2 x's underneath. For the y's, y to the 6th, if you divide 6 by 3, you just bring out a y squared. So the simplified, we can bring out a 2, an x, a y squared, but we cannot bring out an x squared. So this would be how number 14 simplifies. Number 15, we would simplify the square root of 12, simplify x to the 8th, and simplify y to the 11th. This is 4 times 2. Okay, 4 times 2, or sorry, 4 times 3, my mistake. This is 4 times 3, 12, and 4 is made up of factors 2 and 2. So this 4 we could take a square root of, but we still have the 3 underneath. The index is 2, by the way, index of 2. So x to the 8th, 8 divided by 2, becomes x to the 4th. And y to the 11th, 2 goes into 11 5 times, but you have a remainder of 1, so you still have a y underneath. So what do we have on the outside? 2, x to the 4th, y to the 5th, and then underneath I have a 3y. Number 16, so we have the 4th root of 32, we have the 4th root of x to the 3rd, and we have the 4th root of y to the 9th. 32 is made up of 5 factors of 2. So 4 factors of 2 can come out, but there's still 1 that's left underneath. X to the 3rd, we need at least 4 factors, and we only have 3, so that's not going anywhere. And y to the 9th, 9 divided by 4, so 2 factors of y come out, and we're still left with a factor of y underneath. So what did we bring out? 2y squared. And what do we have left underneath? A 2, an x cubed, and a y. To write in radical form, very simple. We just use the denominator as the index, so the 4th root of 4x squared. The 5th root of x cubed, and the 4th root of 3x squared y cubed. Writing in exponent form, also simple, the index becomes the denominator, so this is x to the 4/3. The minus 4 doesn't have an exponent, or a radical, so it just stays the same. This is 2x. You could write this with the 1/2 on the outside, or you could write this as 2 to the 1/2, x to the 3/2. So the index is 2, so each of these get a denominator of 2. And then this one would be 1 over x to the 2/3. The 3 becomes the denominator for that. Evaluate. So we'll turn each of these into a radical. So first we got to make this positive. So 1 over 343. And now it's raised to the positive 2/3 power. We put it on the bottom. Now 343, we'd be looking for the cubed root of that because of the denominator of 3, and then we'd be squaring that. The cubed root of 343 is 7, so it's 1 over 7 squared, which is 1 over 49. So this evaluates to 1 over 49. Number 24, we have, if we wrote this as a radical, it'd be the square root of 49, that's then rose to the 3rd power. Square root of 49 is 7, and 7 through the 3rd power is 343. So 49 to the 3/2 is 343. And then lastly, we have 8 to the 5/3, so that's the cubed root of 8, that's then rose to the 5th power. So cubed root of 8 is 2, because it's made up of 3 factors of 2, and 2 to the 5th power is 32. And that's all of our problems here.